Hello all, welcome to our session on the ZTNA. ZTNA stands for Zero Trust Network Access. ZTNA is a security framework and architectural model that operates on the principle of zero trust. It focuses on providing secure access to resources based on user identity, device posture, and contextual factors, rather than relying solely on network perimeters. ZTNA is a product or service that creates an identity and context-based, logical access boundary around an application or set of applications. The applications are hidden from discovery, and access is restricted via a trust broker to a set of named entities. The broker verifies the identity, context, and policy adherence of the specified participants before allowing access and prohibits lateral movement elsewhere in the network. This removes application assets from public visibility and significantly reduces the surface area for attack. ZTNA differs from virtual private networks, as in ZTNA they grant access only to specific services or applications, where VPNs grant access to an entire network. ZTNA specifically does the following. It controls whether network traffic is allowed to flow based on policy. It treats policy as dynamic in real time. It defaults to blocking all traffic. It allows a traffic flow only when a policy explicitly allows it. It verifies the identities of all parties to a network flow before allowing it. It verifies, as best it can, that endpoints are still secure. It does not grant implicit trust to any entity on the network at any time. And finally, it can be context-aware, with policies that take into account anything, from time of day to geographic location of a user or endpoint. Let's understand ZTNA components. Components include: first, we have user identity, that involves user authentication and authorization processes. Second, is policy engine, which is responsible for evaluating access requests based on predefined policies. Next is secure access broker or gateways. It acts as intermediaries between users and resources. They establish secure connections, enforce access policies, and provide authentication and encryption mechanisms. Next is microsegmentation, that divides the network into smaller segments. This allows for fine-grained access controls and limits lateral movement within the network. Next component is secure tunnels and encryption. ZTNA utilizes secure tunnels, such as transport layer security, or virtual private networks, to establish encrypted connections between users and resources. Next, we have continuous monitoring and analytics. ZTNA architectures often include monitoring and analytics capabilities to detect anomalies, suspicious activities, and potential security breaches. Next, we have integration with identity and access management systems. ZTNA architecture integrate with IAM systems to ensure consistent user identity management, centralized access control, and alignment with organizational policies. Next is application and resource integration. ZTNA must integrate with the applications and resources it protects. This can involve implementing APIs, client software, or agent-based approaches to enable secure access and enforce access policies at the application level. Lastly, we have logging and auditing. ZTNA architectures typically include logging and auditing mechanisms to track access events, monitor policy enforcement, and support compliance requirements. Moving on. The key characteristics of ZTNA include secure access. ZTNA provides secure access to applications and resources based on the principle of least privilege, ensuring that users have access only to the specific resources they need. It provides an identity-centric approach. ZTNA emphasizes user identity as the primary factor for granting access, often utilizing techniques such as multi-factor authentication and strong user authentication mechanisms. Next, it provides microsegmentation. ZTNA incorporates microsegmentation techniques to enforce access controls at a granular level, segmenting resources and limiting lateral movement within the network. And lastly, it provides an user-centric policies. Access policies in ZTNA are based on user attributes, device posture, and contextual factors, allowing for dynamic and context-aware access decisions. I hope the video was useful. Please email us if you need a copy of this presentation. Please subscribe to stay on top of all upcoming videos.